Today we'll talk about multiplying and dividing rational expressions. Let's start with multiplying. To multiply rational expressions, we're going to do these steps. Step 1, factor and combine the numerators. Just kind of put them together, multiply them. 2, factor and combine the denominators. And then we're going to put all of the numerators from both of these expressions together on kind of one line on the top. We're going to put all these factors for the denominators on one line in the bottom, creating just one kind of big fraction. And then we're going to simplify by canceling, dividing out any common factors. We want to also note any of the excluded values, even if they were canceled. So let's take a look. For my first example, I've got 3x squared over x squared minus 2x minus 8. I'm multiplying that to 2x squared minus 6x minus 20 over x squared minus 3x minus 10. So let's deal with the numerators first. So we'll just call this the top. And we've got the following: 3x squared. Well, this is just going to factor to 3, and then I can leave either x squared as x squared, or some people prefer to just say this is x and then another x. Okay, what else do I have? I have 2x squared. Let's write that down. 2x squared minus 6x minus 20. And I can see that I can take a 2 out of this right away. If I do that, pull that to the front, I'm left with x squared minus 3x minus 10. And then I can factor this using that AC method. A equals 1, C equals negative 10. Okay, so I want all the things that multiply to 1. That's just 1 times 1. And all the things that multiply to get negative 10. So 1 times negative 10. 2 times negative 5. Let's see, and then I should also do 5 times negative 2 and 10 times negative 1. Now I'm trying to get negative 3x out of this. So my trick for a equals 1 is I can just add these together to see which one makes negative 3. So 1 plus negative 10, that'd be negative 9. 2 plus negative 5, that would be, oh, that one's negative 3. Okay, so it's 1, 1, and then 2, negative 5. This means that 2x squared minus 6x minus 20, this will factor to two binomials. 1, 1 means x here, and then 2, negative 5, so plus 2, minus 5. And then don't forget, I've pulled a 2 out to the front, so we've got 2 out here as well. Okay, so that's the top part. Now we'll do the bottom part. This is going to be the denominators. So let's start with x squared minus 2x minus 8. Factoring this, a equals 1, c equals negative 8. So 1 times 1. And then for negative 8, I've got, let's see, 1 times negative 8, 2 times negative 4, 4 times negative 2, and 8 times negative 1. So trying to find negative 2 here, that's going to be 1, 1, and then 2, negative 4. So x plus 2 minus 4. Then I've also got x squared minus 3x minus 10. And actually, we factored this earlier. That's this one right here. We just happened to pull a 2 out to the front before because it was 2x squared minus 6x minus 20. So I actually know that this factors to x plus 2, and then x minus 5. Now what you're going to do with all of this is you're going to write the top parts all in one line and the bottom parts all in one line. So that's going to make 3 x, x, and then 2 x plus 2, and x minus 5, all over x plus 2. Now all the bottom parts, x minus 4, x plus another 2 here, and then x minus 5. So this is the top, this is the bottom. What I'm going to do is I'm going to start dividing things out. So I've got an x plus 2 on top and an x plus 2 on the bottom. I've got an x minus 5 on top and an x minus 5 on the bottom. And I don't have anything else that is both on top and bottom. So I'm going to stop there. And I'm going to say what is left over. So I'm left with 3 times x times 2. Let's call that 6x squared over, on the bottom, I'm left with x minus 4 and x plus 2. But I have to say that x cannot be, what would make this 0? Well, 4, because 4 minus 4 would be 0. So x cannot be 4. X cannot be negative 2. And then I look at the things that we divided out, and I go, okay, I've got another x plus 2, but I already took care of that with this one. And I've got an x minus 5. So what would make that 0? A positive 5. So my answer here is 6x squared over x minus 4, x plus 2, but x cannot be 4, negative 2, or 5. All right, let's look at the next one. Multiply this, x squared plus 8x over 14 times x squared plus 8x plus 15. I'm going to multiply that to 7x plus 35 over x plus 8. All right, so let's begin with the top parts. X squared plus 8x. I see that these have an x in common, so I can bring that out to the front. And I will be left with x plus 8. Okay, and then this other one, 7x plus 35. I see that I can bring a 7 out to the front. And when I do that, I will have x here plus 35 divided by 7 is 5. Okay, now let's do the bottom parts. For the bottom, I've got 14 times the quantity x squared plus 8x plus 15. So we're going to factor this. So a equals 1 here, c equals 15. So this is 1 times 1, and for 15, I've got 1 times 15, 2 times, oh, nope, not 2, 3 times 5. And I can see that to find 8, I'm going to use 3 and 5, because 3 plus 5 is 8. So this will factor to x from 1 and 1, and then 3 and 5, so plus 3 here, plus 5 here, and don't forget we've got a 14 at the front. All right, I've also got x plus 8. Luckily, I don't have to do anything with that. That's just going to be x plus 8. Okay, now we're going to put the top over the bottom. So top over bottom. Putting all of the top parts together, these factors, I'll get x plus 8, 7, x plus 5. This will be all over 14, x plus 3, x plus 5. And then another x plus 8. All right, let's start dividing some things out. I see I've got an x plus 8 on the top and the bottom. And I've got an x plus 5. And we'll write what's left over. Now I also notice that I've got a 7 on the top and 14 on the bottom. 14 is the same as 2 times 7. So I'm going to make this 2 times 7 and then divide the 7 out from the one on top, leaving just x over, this will be 2, and then x plus 3. But I also have to say x cannot be a few things. What would make my denominator 0? Well, if x was negative 3 plus 3, this would be 0, so x cannot be negative 3. For x plus 5, x cannot be negative 5. And for x plus 8, x cannot be negative 8. All right, and that takes care of multiplying. Let's look at dividing, which we're not actually going to do any division when we divide rational expressions, because as it turns out, dividing rational expressions, I'm just going to multiply by the reciprocal of my second expression instead of dividing. So this takes care of having to do something really, really complicated. With the division, I can simply say, for example, x plus 7 squared over x squared, instead of dividing by x squared plus 9x plus 14 over x squared plus x minus 2, this is the same as saying x plus 7 squared over x squared, so that's going to remain the same. But instead of dividing, I'm going to multiply by the reciprocal of the second expression here. So just flip the top and the bottom. The top will be x squared plus 8x, or no, x squared plus x, sorry. Minus 2. And this will be over x squared plus 9x plus 14. So don't do division. Actually, we'll just multiply. And since this is the same as the other two problems that we did, we're going to use the exact same process. So we'll say the top part is x plus 7 squared well, here we can just say that that's x plus 7 times another x plus 7. And I've got x squared plus x minus 2. Let's factor this. A equals 1, c equals negative 2. So I've got 1 times 1 here, 1 times negative 2, and 2 times negative 1. So trying to find a positive 1x, that's going to be the 2 times negative 1, because 2 plus negative 1 will make positive 1. So this will factor 2. 1, 1 means x here, and 2 negative 1, so plus 2 minus 1. Okay, the bottom parts. I've got x squared. So I can just say that this is x times x. And I've also got x squared plus 9x plus 14. And we will factor this. A equals 1, C equals 14. Okay, 14. So that's 1 times 14, 2 times 7. All right, to get 9, I'm going to use 2 and 7. 2 plus 7 makes 9. So this will factor to 1, 1 means x here, and then plus 2 plus 7. So putting the top over the bottom, all of these together, the top part will be x plus 7, x plus 7. And then an x plus 2, x minus 1. This is over the bottom parts, x, x, x plus 2, and x plus 7. And just like before, we'll divide out what the top and bottom share. So I've got an x plus 7 on top and x plus 7 on the bottom. I've also got an x plus 2 on top and x plus 2 on the bottom. And then we'll write what's left. So I've got x plus 7 and x minus 1 on top. And this is over x times x. We'll just say that's x squared. But x cannot be, let's see, this would be 0. If I make 0, x is 0, then it'd be 0 squared is 0, can't divide by 0. So x can't be 0. And then I go through all the things that I divided out as well. So x plus 2, negative 2 would make that 0. And x plus 7, negative 7 would make that 0. So x plus 7, x minus 1 over x squared. X cannot be 0, negative 2, or 7. Okay, last one. Divide 6x over 3x minus 30 by 9x squared minus 27x minus 36 over x squared minus 10x. Now remember, doing this with actual division here might be really complicated, but I have a shortcut. Instead of doing that, I'm just going to keep the first one exactly as it is, 6x over 3x minus 30. And instead of division, we're going to multiply by the reciprocal of the second expression. So we're just going to flip this upside down. So we're going to multiply by x squared minus 10x all over 9x squared minus 27x minus 36. And now it's just like all the other problems that we've done today. So we'll take a look at the top parts first. 6x, well, let's just separate the 6 and the x. And x squared minus 10x. I see they have an x in common. Let's bring that to the front. And got x minus 10 left over. All right, now let's go through the bottom parts. For the denominators, I've got 3x minus 30. These two have a 3 in common. We'll bring that out to the front, leaving x minus 10. And then 9x squared minus 27x minus 36. All three of these have a 9 in common. They're all divisible by 9. So let's take the 9 out to the front. let's see, what's that leave us? X squared minus 3x minus 4. Now I'm going to factor that part. A equals 1, C equals negative 4. So this is 1 times 1. For negative 4, I've got 1 times negative 4, 2 times negative 2, and then should also do 4 times negative 1. Okay, let's see. To get negative 3, I'm going to want 1 times negative 4, because 1 plus negative 4 will make negative 3. So this will factor to 1, 1 means x here, 1, negative 4, so plus 1 minus 4, and don't forget, we took a 9 out at the beginning. Okay, so now let's put the top over the bottom. All the parts for the top over all the parts for the bottom. So 6 times x times another x times x minus 10, that's the top part, over the bottom part, I've got 3 times x minus 10, and then 9 x plus 1, x minus 4. Let's divide some things out here. So I've got an x minus 10 on the top, an x minus 10 on the bottom. Okay, and then I'm also noticing that I've got a 6 on the top and a 3 on the bottom. So I can divide 6 by 3 and make 2 on the top. So that'll be 2 left over on the top. X times x will be x squared. Now that 3 divided out with 6 times 2, so I'm going to be left with a 9 down here, and then an x plus 1, and an x minus 4. Lastly, I say x cannot be a few things. What would make the denominator 0? Well, negative 1, because negative 1 plus 1 would be 0, so x cannot be negative 1. X cannot be positive 4. And I'll take a look at what divided out. X cannot be positive 10. All right, and that's how we multiply and divide rational expressions. We separate the top from the bottom, find all the factors for the top, all the factors for the bottom, and write them all out in one line, divide out what we can, and write what's left over, saying what x cannot be. Those are our excluded values. For division, remember, don't actually divide, just multiply by the reciprocal of the second expression.